Good afternoon, class. This is practice test number 2 for module 2, covering chapters 4, 5, and 6. Here's chapter 5 and chapter 6, polynomials and factoring. Before we start, let's have a general review of factoring. First, we need the GCF, the greatest common factor. Then we consider the number of terms. If we have 4 terms, we factor by grouping. If we have 3 terms, we either have a perfect square trinomial of the shape a squared plus 2ab plus b squared or a squared minus 2ab plus b squared. The first one becomes a plus b quantity squared and the next one a minus b squared. Or not a perfect square, in which case we either have a equals 1, so we get x squared plus bx plus c. So we want 2 factors of c. That means we want 2 numbers, the product is c and the sum is b. We write it in this format, x plus the first number times x plus the second number. Or a is not 1, in which case you use either the trial and error or find 2 factors of ac whose sum is b. Write these factors as coefficients of 2 like terms that when combined equal bx, and then factor by grouping. You've seen many examples we've done in our PowerPoints. And if it happened to be 2 terms, there are 3 possibilities. A difference of squares, a squared minus b squared, which is a plus b times a minus b. A sum of cubes, a cube plus b cubed, which is a plus b times a squared minus ab plus b squared. Or a difference of cubes, a cube minus b cubed, which is a minus b times a squared plus ab plus b squared, or it will not be factored. We can't factor. What I want you to pay attention to is this number. You see, this one makes it a perfect square, whereas this one has plus 1 here, and this one has minus 1. So this second piece here is not a perfect square. On the right column, I have some exponential rules, such as the zero exponential rule, the product rule, the quotient rule, the power rule, the negative exponential rule, just reminding you of all those rules that hopefully everybody remembers so we can easily move on. We want to simplify this. When you do order of operations, it's important to know we do the grouping symbol first, and we do the exponents, then multiplication, division in any order it happens, and finally addition, subtraction. If you understand that everything gets separated by either the minus sign or plus sign, then this is separated from this one, from this group, from this group. So if you understand that, really order of operations becomes simple. We do this becomes 9. We do this becomes 9 times 4. We do this becomes 8, don't forget the negative remains. We do this becomes 4, the negative remains because it's not negative to quantity squared. So I want to make sure everybody understands what's happening here. So I'm going to write the following. So minus 2 squared is minus 2 times 2, which is minus 4. However, minus 2 quantity squared is minus 2 times minus 2, which is positive 4. So please understand this negative remains because of the order of operations. 4 times 9 is 36. And so minus 4 minus 8 plus 36 plus 9, they add up to 33. 2x minus 3 to the power of 0, anything to the power of 0 equals 1. So 2x minus 3, 5 to the power of 0, or 2x minus 3 to the power of 0 makes no difference. It is equal to 1. Again, order of operations. To do order of operations, it helps if we understand what happens here, which is 4 to the power of negative 2 plus 3. And we're going to say 4 divided by 3 to the power of minus 1 means 1/3 minus, we use the exponential rule, 4 to the power of 1. So 4 divided by 1/3, that means 4 times 3 over 1, which is 12, minus 4, which is 8. Simply put, order of operations. To raise this to the power of -1, it's important to know that you have many, many exponential rules. It was shown on the first page. You can do them in any order. You can simplify this, then raise it to the power of -1, or you can raise it to the power of -1. The very first thing we should notice is that b cancels out the b. And so anytime you have a negative exponent, you can move it, make it positive. So depends on which method you want to go. If right now, when I apply the power rule, this becomes -4, this becomes +2, this becomes +3, this becomes -2. If we go this route, I want to show you this method, and I will explain the second one. Anytime you have a negative exponent, this one moves down, becomes a to the power of +4, this goes up, c to the power of 2. So they add up to 4, so c to the power of 4, they add up to 7 over a to the power of 7. This is one way to do it. Another way of doing that would be to here, you can write it as a to the power of 4. Let me see if I have room. I have room here. A to the power of 4, you keep it up. C squared, you keep it up. Now c to the power of -2 goes down and it becomes c squared. A to the power of -3 comes up, becomes a to the power of 3. To the power of -1, which becomes a to the power of 7 over c to the power of 4 to the power of -1, and it gives you the same answer. So this is in case you want to go a different route, depending upon what is easier for you to do. The next one is cube root of -64. There's a number, you raise it to the 3rd power, you get -64, which is -4. And we do not want to mix it up with the square root of -64, which is not a real number, it's 8i, where I is the square root of -1. We don't want to mix them up. To do this, we raise 2 to the power of 2, we get 4, x squared, y to the power of 6, x to the power of 6, and -1 times 3 is -3. So we write it in this fashion. So I hope you realize 4 remains up there, x squared cancels out the x cubed, gives you x. This -3 goes up, y cubed and y to the power of 6, they give us y to the power of 9. Perhaps it's a good practice to get rid of this and put it up here. And then these 2 will result in this. 2/3 to the power of -2, you can flip it over to the power of +2, and that means 3 squared, which is 9, over 2 squared, which is 4. What is the degree of each polynomial? I hope you realize this has a degree 3, this has a degree 2, this is a constant, has a degree 0, but the degree of a polynomial is of the highest degree, and this happened to be 3. The answer is 3. This one is 3, this one is 2 plus 2, 4, this one is 0, so 2 plus 2 or 4. Because there are different variables, and being multiplied, because they are being multiplied, and that's the key, you add up their exponents. We want to subtract this expression from this one, so we write it in this fashion. We are going to apply the negative sign, so we repeat this part. This becomes plus x squared minus 3x minus 5. So 4x squared adds up to x squared, and that gives us 5x squared, negative 6x, and negative 3x, negative 9x, positive 2, minus 5, negative 3. So we add up like terms. 8x cubed plus 27. This is one of those special factoring. I hope you remember this special factoring. Again, I repeated it at the top right so you can see that. Notice 8x cubed means 2x to the third power, and this means 3 to the third power, which means if I go to this one, this is my a, 2x, and number 3 is my b. So according to this formula, a plus b, that means 2x plus 3, and then a squared, that means 2x quantity squared, minus ab, this product of the two, 2x times 3, so with a negative sign, minus ab, minus 2x times 3, and then plus 3 squared. So just follow this. Now, this is important that you put it in a parenthesis because this becomes 4x squared. I've seen students making a mistake of writing just simply 2x squared, which is wrong. This is 2x quantity squared, which makes it 4x squared minus 6x plus 9. And please understand, this is not a perfect square trinomial. Here, a cubed minus 8b cubed. This is obvious, but this is minus what? 2b to the third. And now we're going to follow this one. So we're going to write a minus 2b. Let me just write that. So this becomes a minus 2b. Then we have a squared plus ab, right? So plus a times 2b plus 2b squared. Now, on purpose, I wrote it wrong. I want to make a point. What is wrong with my writing is that this has to be in a parenthesis because otherwise one might think it's just simply 2b squared, whereas this one is 2b quantity squared ends up being 4b squared. So pay attention to that and why we should put that in a parenthesis. We are factoring. Now, if you want to go by the substitution, let x squared be, let's say, y, anything except x. You can write y squared minus 5y minus 36. Or you may notice that if you write this as x squared and the second parenthesis as x squared, then it works out like the simple factoring you've seen. You want two numbers, the product is negative 36, and the sum is negative 5, so you get positive 4 and negative 9. Now, x squared plus 4, there is nothing we can do, but this one we can factor it into x plus 3x minus 3. You always factor completely if you can. I hope you realize this is 9 squared minus z squared squared. In other words, I am following this formula, special factoring. So this becomes 9 minus z squared, 9 plus z squared in any order. This, there is nothing I can do about it, but the first piece, I can write it as 3 minus z, 3 plus z in any order. And now this is completely factored. The first step is always GCF. If there is any, 4 comes out. And now you want two numbers. The product is negative 4. The sum is negative 3. And that's an easy case. So x minus 4, x plus 4. You want to take out the common factor, the GCF first. 2 between 2 and 6, 2 is in common. Between x squared and xx is in common. Also y is in common. So 2xy. You divide this one by the first one, results in y. You divide this one by common factor, results in this. And there is nothing else we can do to factor this further, and we are done. We have 1, 2, 3, 4 terms. That means factor by grouping. The way the grouping works, do the first two and the last two together. If it works out, fine. If not, the first and the third. If not, the first and the fourth. So let's put the first two together and the last two. This a comes out. This one, negative 2, comes out. We are hoping to get the same parentheses. They must be identical, otherwise it can't be done this way. We have to take it another route. This is perfect. A plus 3 is in common. You write that, and what is left from the first part, A, what is left from the second part, -2. So take a look. A plus 3, then A from the first part, -3 from the last. We are done. Now, to do this, you can square that, multiply by 6, do the math, but the best course of action is to do it by substitution. It makes it easier. Let p minus 5 be anything except p. You can choose x, y, z, m, u, you name it. So you have the following. Now to factor this out, you have 3 methods. Remember the trial and error, the AC method, and the method that I mentioned in my PowerPoints. I'm going to discuss that with you right here in a moment. But for now, when you factor it, this is what you get. And always check the middle term. This is easy. 2x times 3x is 6x squared. 3 times 1 is 3. But the product of these two, which is 9x, the product of these two, which is 2x, they add up to 11x. Yes, there is, then it's correct. Now remember, the original one involves p, therefore x must be changed to p minus 5. When you do that here, you get 2p minus 10 plus 3 here, 3p minus 15 plus 1 here, and you add up like terms, you get 2p minus 7 times 3p minus 14. What I want to remind you is this factoring that was mentioned. The third method that I showed in my PowerPoint is that you put, if you're factoring ax squared plus bx plus c, you put ax and a here. Please understand the variable is x. If the variable is anything else, let's say y, you use that variable. So if a is not 1, this is the fastest way. So ax, and a. So in this question, and I'm going to go back to this part because I want to factor this one. This is the one that we want to factor. So what is a? 6, put it in. So a is 6. So 6x, 6. Now we want a times c. A is a 6, c is 3. We want their product, which is 18. So we are looking for 2 numbers. The product is 6 times 3, 18, and the sum is b, 11. So we want 2 numbers. The sum is b or 11. The product is a times c, which is 18. So I hope you can easily do that in your head and you realize the numbers are 9 and 2. Because they both starts with 6, it doesn't matter where you put those numbers. Put them anywhere you want. By the time we finish the job, this denominator must go away. I want you to know that. So this one, the first one, 3 is in common. The second one, 2 is in common. And notice the product of 3 and 2 is 6. And what you have left is 2x plus 3 times 3x plus 1. And that is exactly what we have here, or here when we did the factoring. So this is the third method. If you practice that, you will see that it's a very nice and easy method to take care of the cases where a, you're dealing with a trinomial and a is not 1. You want to factor this, you take out the common factor. I hope you realize the GCF is 4x. You take it out. It's a simple case. You want 2 numbers. The product is -12 and the sum is +1. Again, let me just quickly show you what I mean by that. So you would write 4x and you would put the x here and x here. So you want 2 numbers. The product is -12 and the sum is 1. And so we end up with, this is x, by the way. So x is 0, x is -4, and x is 3, everybody. We distribute the x, we get x squared minus 12x. We bring the -20 to the other side, becomes positive. We do the factoring. We want two numbers, the product is 20, the sum is -12, x minus 2, x minus 10, so x is either 2 or 10. We want to multiply, so we distribute these two, and these two, and I hope you realize for this one, x has exponent 1, y has exponent 1, that's what we get here. So 1 and 2 is 3, and this one also has exponent 1. Therefore, 1 and 2 is 3, 1 and 3 is 4. This one, 4 times -20 is -80, x squared, x to the power of 5 is x to the power of 7. These 2, 3, and 7 is 10. When you multiply these two, 4 and -2, the product is -8. You keep the x squared, y cubed, and y to the power of 1. Becomes y to the power of 4. You distribute the 2x, you get 6x cubed here, over here, minus 2x squared, and over here, plus 4x. Now multiply by 1, simply write the second one. And I hope you realize that you have to put this in descending order, which means you are going to add these two because they're like terms. So you get 6x cubed plus x squared, and then 4x with negative x, they result in 3x. Don't forget the number 2. This one we use a plus b quantity squared, which is a squared plus 2ab plus b squared, where a is 2x and b is 5. So the first one becomes 4x squared. This becomes 20x, and finally 25. We want to find all the x-intercepts, which means we have to set y equal to 0. We factor by taking 3x out. Now we need to factor this. The factor is as follows: 4x minus 5, x minus 2. And when you set this one equal to 0, you get 0. You get 5 over 4 here, and you get 2. Now, because you want x-intercepts, write them in pairs as follows. 0 means 0, 0. 5 fourths means 5 fourths, 0. 2 means 2, 0. What I want to quickly show you, again, the same method that I discussed for you. The factoring here, a is 4. And a is 4. C is 10. AC is 40. And B is -13. So you want two numbers, the product is AC and the sum is B. So -5, -8, and I hope you realize in this case, we can take the 4 out, we get x minus 2, this 4 cancels out this 4, and it gives us this. So I'm showing you the method that works. One leg of a right triangle is 4 centimeters less than the other one. The area is 70. Determine the length of each leg. Set up a system of equations and solve. First, if this is x and this is y class, it's important to know that the legs become the base and the height. So one leg is 4 centimeters less than the other one. So x is smaller, so x is y minus 4. And I hope you remember that the area is 1/2 base times the height, and the two legs are that. So x is y minus 4, and 1/2 base times the height. 1/2 x times y is 70. And as long as you have those two equations, you're practically done. To solve this, you change this to xy equals 140. In other words, you multiply by 2. It makes it easier that way. And replace the x with y minus 4. If you distribute, you get y squared minus 4y. Move the 140 becomes negative 140. Now you want two numbers. The product is negative 140. The sum is negative 4. Y is either 14 or negative 10. Sides can't be negative, so negative 10 is out. If y is 14, x must be 4 less. That means 14 minus 4 or 10. Write the units. Notice their product divided by 2 is also 70, which works. You want to divide, we make up 3 fractions whenever the denominator has only one term. And now that's the easy one. The 3 cancels out. This is x squared. This is y to the power of 4. Minus, this is 4. X cancels out, y to the power of 9. This is 7 and minus 7. The last question. When you want to divide this, you have 2 choices. You can do long division, and you write it as follows. You divide the first term by the first term. X squared divided by x is x. You multiply it by x plus 3 becomes x squared plus 3x. We're going to subtract this from this, so we make this minus, they go away. If we make this minus, it becomes minus 4x. You drop the negative 13. Now you divide this one by the first term, gives you negative 4. Multiply by it, you get negative 4x minus 12. We are going to subtract this from the top, so minus negative 4x. This is 4x cancels out. This is positive 12. They give us negative 1. Therefore, the answer is this with this remainder. And the way you write it is as follows. You can say this is x minus 4 minus 1 over x plus 3. Or you can say this is equal to the product of these two with negative 1. So take a look. This is fine. This is fine. The divisor times the quotient plus the remainder. The remainder happened to be negative 1. I want to go over the synthetic division, which is coming up in the next courses. If you learn it, fine. If you want to do it that method, that's fine. Here's what you do. You write the coefficients, 1, negative 1, negative 13. And if anything is missing, you have to put a 0. Because we are dividing by x plus 3, you put negative 3. If we were dividing by x minus 3, we would put positive 3. We drop the first number. Then we multiply these two and we put it here, becomes negative 3. Add them up, becomes negative 4. We multiply them again, becomes 12. Add them up, becomes negative 1. Because this is of degree 2 and this is of degree 1, you go down by 1. And this is 1 times x minus 4 with the remainder negative 1. In other words, this gives you the same answer as this one or this one.